got your parabola shape, wherever it might be, and it has a little spot in it called the focus. Again, we get away with a lot of things in this chapter that we don't have to learn, but I just want to mention it because I think it adds to the appreciation of it. But this little spot called the focus, it's guaranteed that all the signals, whenever they're lined up parallel coming into this curve, they'll bounce into that particular point. So as long as all these parallel rays are coming in, so the satellite's lined up just right, it catches the signal, focuses all the energy into that one mathematical spot in the parabola, and then you've got your clear picture. Same idea with your cell phones and all the towers and signal and so on for that. All right, so you gotta love the parabola. Okay, page 2. I used to have a video with this guy getting his kidney stones crushed. Have you seen my kidney stone? I show it some semesters, but it's been borrowed by somebody and I can't find it now, but I love it. It's an ellipse application. And the neat thing about an ellipse is it has two little spots, mathematical spots in it that we could find if we had to. There's formulas in your book and it shows you how to do this. But it has two spots. Mathematically, if one of the rays of whatever you're trying to do goes into one of the dots, it has to bounce off of the figure, the elliptical figure, into the other spot. So it has two foci. So the miracle of that would be this kidney stone application on example 7. And like I said, I used to have this video and it showed how they lined up somebody's kidney stone with the mechanism that was elliptical shape, mathematically went through the elliptical mathematical equation. It matched up with that in all ways. Line that up, and then all the power of the ray is guaranteed to go into the kidney stone if it can be found on the x-ray in your body. And so that process, that procedure is how they do lithotripsy, maybe, and they're able to crush your kidney stone, and it's math. Well, everything is math, I guess they always say. Everything boils down to some math. But that's that equation. The ellipse equation is what allows them to use that process of crushing kidney stones, gallstones, against whatever. The other one, the other example I like, is the one above it. And it says the Whispering Gallery in the old Capitol building. If anybody's ever been to D.C. and did the Capitol building tour, they always take you through this one room they call the Whispering Gallery. And they have a little disc on the floor where they show you where John Quincy Adams' desk was. It says John Quincy Adams was able to listen to his opponent's conversations because his desk was positioned at one of the foci beneath the ellipsoidal ceiling. So the ceiling is shaped like an ellipse in that room. And so it just so happened that his desk was lined up at one of these spots and his opponent's desk was lined up at the other spot. And so the noise bounced off the elliptical ceiling, and so he could hear even a whisper. So if you go on this tour and you get down next to the little spot and you listen, and then they always have somebody go to the other side and listen or say something, you can hear even a whisper from that other spot. The two foci, two spots there. Anybody done that tour? Okay, so that's really cool. I just think that's just great. And so that ellipse technology can be expanded to lots of other things. Then on the next page, I have still a note to myself to take my own picture because I passed one of these shapes every time I go to Lawrence County. I teach this class in the spring at Lawrence County, and every time I pass their AEP plant, I always think I'm going to stop and take that picture because they have the cooling towers, and the shape of the sides of the cooling tower is the hyperbola curve. These are mathematically modeling a hyperbola curve. And I can't tell you all the technology behind why they're shaped that way, but I do know those are definitely hyperbola curves, and it's an efficient way for them to cool the steam that comes out of that plant. And then, let's see, next page. Another application of the hyperbola curves They show on the next page is GPS technology, the finding a signal that way. Then at the bottom of the page, the Roman Colosseum was shaped like an ellipse. And a lot of, like the Paramount, they have shaped those specific places in a way so that the sound resonates off the ceiling and out of the wall. It resonates beautifully in that hall, and it has to do with math as well. So everything has some design to it around math. And so the Roman Colosseum is an example of those. And I didn't write down an example of a circle, but lots of examples of circles. I guess you see that all the time. But finding the epicenter of an earthquake, they use circles to figure that out as well. All right, so now to fully appreciate conic sections, we will talk about how to just do the basic graphs of these and sketch them. All right, so I'm going to start with this parabola